Wave sound and simple harmonic motions include 4 equations that you need to know. The first one, the speed of a wave is wavelength times the frequency. The second one, the period of a spring is 2 pi times the square root of m over k. The third one, period of a pendulum is 2 pi times the square root of L over G. And the fourth one, the period is 1 over the frequency. The first equation can be used for waves only. Do not use it for a pendulum. Do not use it for a spring. Second one is for springs only. Again, use it only for springs. The third one is for a pendulum. Again, use it only for a pendulum. The fourth one can be used for anything and everything. We'll start off with waves. Waves. The big things you're going to need to know is be able to count how many waves there are. For example, here we count 1, 2.5 waves. Let's say this whole span was 25 meters long and it was 8 meters tall. A couple of questions are going to be asked. What is the wavelength? What is the amplitude? We'll be given a frequency of 4 hertz. What is the period? What is the speed? The wavelength. Since there are 2.5 waves across 25 meters, we're going to take 25 and divide it by 2.5. That makes 10 meters per wavelength. The amplitude. Big mistake that people make about amplitudes, they like to think that it's 8 meters because that's the difference between the crest and the trough, but it's not 8 meters. Instead, it's only from the equilibrium to the crest or from the equilibrium to the trough. Therefore, it's half of 8 or 4 meters. The period. Period is 1 over the frequency, so it's 0.25 seconds. The speed. We're going to use the first equation that we talked about over here. We can use it because it's a wave. V is 10 times 4 or 40 meters per second. Waves are a transfer of energy. They move energy from one place to another. The energy is contained in the amplitude. You will not need to know specifically the equation for it, but you will need to know that depends on the amplitude squared. Sound. There are 2 big things to note about sound. One is called echolocation and how it works. So for example, if you're on a canyon and you yell, the sound wave goes across the canyon, bounces off of the second wall, and then comes back to you. Let's say it takes 4 seconds for you to hear your own echo. The speed of sound in air is approximately 340 meters per second. So, one of the biggest mistakes that people make is they like to think that the distance is velocity times time. When they do this, they will come up with 1360 meters. That's how far the sound wave traveled, but the question was asking how big is the canyon. So it was asking for this distance here between these 2 walls. It was not asking for the distance there and back, which is what the 1360 is. So 1360 is wrong. We need to take the 1360 and we need to divide it by 2 because we only want to know how far it is from there and back. That makes it 680 meters. Second thing you need to know about sound is beats and beat frequency. The beat frequency is one frequency minus the other. So if you have 880 hertz and a second frequency of 886 hertz, the beat frequency is 6 hertz. If you have a beat frequency, if you have a frequency of 440 hertz and you hear a beat frequency of 3 hertz, that means your second frequency is one of 2 things. It's either 437 or 443. You won't be able to solve which one it is exactly, but you won't be given both options. You'll only be given one of the 2 options. Next is simple harmonic motion. Simple harmonic motion deals with either a pendulum that swings back and forth, or a spring that hangs and bobs up and down, or swings back and forth. If we're talking about a pendulum, length is a key thing that affects it. Gravity does too, but gravity affects most things anyways. Amplitude. Often people think it affects it. It does not. Mass, another big one. People think it affects a pendulum. It does not. Spring. Mass does affect the spring, but length of the spring plays no role in it. The amplitude, just like for a pendulum, plays no role into it. Unlike the pendulum, gravity plays no role into the period of a spring, but what does is what's called the spring constant. Remember that the period of a spring is 2 pi times the square root of m over k. K is your spring constant.